Okay, so we're looking at this and it says, are the five major types the best way to categorize chemical reactions? And actually, the five types that we have, the single replacement, double replacement, synthesis, decomposition, and combustion, they're usually not the best way to categorize it. That's what we use mostly in high school. Anytime we get into college level chemistry, we're talking about AP Chem or anything like that. And really, in a pre AP class, that we shouldn't classify them using the basic types. We should look more specifically, it's on the electron movement. So, where the electrons are going. So, yes, we do need to know the five basic types of chemical reactions and be able to classify those. But chemists usually look at how electrons are moving, because remember, chemical reactions, it's all about the valence electrons. So chemical reactions occur because of the interactions of those valence electrons. That's what we really care about, and that's how we're going to classify the majority of things. Got to know the basic types, but let's get a little bit deeper into how we actually classify. Now, what is the best way to categorize chemical reactions? Well, how all chemists organize chemical reactions is through oxidation reduction reaction, and we have neutralization reactions, and here we're also adding in, we'll talk about precipitation reactions, and that's really, again, it's another form of these. So oxidation reduction usually happen with single replacement reactions and double replacement reactions. Neutralization reactions are always a double replacement reaction. So we're going to look at those. The first one, how do you know if an oxidation reduction reaction has occurred? So in an oxidation reduction reaction, the oxidation number is changed in an oxidation reduction reaction. So that makes sense. So if we're looking at it, if our iron, anything that's by itself, any element that's by itself, its oxidation number is always going to be 0. So if we have our iron and it changes its oxidative state, now it's +3, okay, that is going to be an oxidation reduction reaction. All single replacement reactions are oxidation reduction reactions. So we always have an element sitting by itself plus a compound, and since that element switches places, that means that its oxidation number will go from 0 to being bonded to something in that compound, which changes its oxidation number. So anytime there's a change going up and down or in the oxidation number, we're going to have an oxidation reduction reaction. So how do you know if a precipitate reaction has occurred? So the three types we're focusing on: precipitate, oxidation reduction, and then neutralization. Okay, how do I know if a precipitate reaction occurs? If a solid appears in solution, you have a precipitate reaction. Okay, so when we look at this, we see that as these two liquids are being poured together, we see that there is a color change, and we see kind of something floating in there. That thing floating in there is that there's a solid. Okay, if we mix two liquids together and nothing appears, then you don't have a precipitation reaction. Okay, nothing's actually happening. They're just the chemicals, the elements are floating in there by themselves. They're not actually having a reaction. They're just what we call disassociated. Or with acids, we say that it's ionized. So this is what we're looking for. Is there a solid appears? How do we determine if a precipitation reaction has occurred? Well, we use the solubility rules, and we're going to talk a lot about this when we talk about predicting it. We like to use our solubility rules when we don't know what the product is, and we're going to predict if there will be a precipitate. If we're just doing a qualitative type lab and we're just looking, does this produce a precipitate reaction? We're looking for that solid. We're looking to see if a solid actually appears. Okay. And lastly, how do you know if a neutralization reaction has occurred? Okay. If the reactants are composed of an acid or a base, then you have a neutralization reaction. So what happens if you have an acid and a base, and you put an acid and base together, what happens? They neutralize. So acids have a very low pH, bases have a very high pH. So if I'm putting something very low in with something very high, what happens is they get right around a pH of 7, which is neutral. That's what water is. Okay, so the question is now, if the reactants are an acid and base, we have a neutralization reaction. What's an acid? For now, acids are anything that have extra free floating hydronium ions in the aqueous solution. What this means is that acids usually begin with H. So HCl, hydrochloric acid, H2SO4, that's sulfuric acid. Anything that usually begins with an H, it has the ability to ionize, and basically what happens is when it's floating in a liquid, it has an extra hydrogen floating around. And what happens is it produces a hydronium ion, which is H3O, with a positive charge. That extra hydrogen floating around kind of hooks up with a water molecule, and it produces that hydronium ion. So basically, anything free floating hydronium ions, or you can just think if it starts with an H, it's an acid. So, what is a base? For now, there are anything that have extra free floating hydroxide ions in the aqueous solution. So, we see that here's the hydronium for the acid. Well, hydroxide, we see that hydroxide, so let's say potassium hydroxide, when it goes into water, it becomes an aqueous solution. Well, it's going to have that extra hydroxide floating around. So anytime you see a hydroxide on the end of it, that's the basic of it. There are some exceptions to that. Like we have ammonia, NH3. That's actually a base. Doesn't have that OH hydroxide, but it is considered a base. For anything that we're going to use right now, just look for that hydroxide. Okay. So, let's look at an example. It says a basic liquid battery can be made using the reaction below. Identify what type of reaction this is. So, when we're looking at it, if we look at the 5 basic types first, we have an element and then an element. Okay, and we look at what's happened. We go from an element plus a compound produces a compound plus a different element. So when we're looking at this, it's a single replacement reaction. Those are the 5 basic types. It's single replacement. When we're looking at this, what's actually happening is that copper has a 0 oxidation number right there. Okay, when it's bonded to sulfate, it has that 2 minus, that -2 oxidation number. So it's changed its oxidative state. We see that zinc right here, zinc would have a oxidation number, and then when it's by itself, it's a 0. Okay, so we see that it changes the oxidation state. It's a single replacement reaction. We know that it's oxidation reduction reaction. Okay, example B2. The titration is one of the most useful tools a chemist can use or can have. What type of reaction is a chemist investigating if drops of the titrant are added until a solid appears? So we're looking for a solid to appear. Anytime a solid appears, we see that we have a precipitation reaction. This solid is coming out, a solid is precipitating out.